So now I will talk about derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. And since there are 6 trigonometric functions, sine, cosine, tangent, cotangent, secant, and cosecant, each of them has its own inverse, and therefore there are 6 functions, inverse functions, and 6 derivatives. So we'll study them all. So here's the first one, inverse sine. Let's say f of x equals sine x, and that means the inverse function f prime of y equals inverse sine of y. And the question is now, what is the derivative of it? What is the derivative of this inverse function? Now, first thing I want to do, I want to change the notation. So I want to say y equals inverse sine of x. Because typically we denote the argument of a function as x. So this will be x and the value of the function is y. And then the question is, what is the derivative of this function? So the idea is that I will translate it back to regular sine. So y equals inverse sine of x is the same as saying that sine of y equals x. And again, the question is, find the derivative of y. And the idea of this is we will treat this function y equals inverse sine of x as an implicitly given function given by this equation. So treat y equals inverse sine of x as a function implicitly given by this equation, as a function implicitly given by this equation, y equals inverse sine x. Y equals sine of y equals x. And now we need to find the derivative of this function, and we will find the derivative by using the method that we typically use for implicitly given functions, and this is left-hand side derivative equals right-hand side derivative. Now start with the right-hand side derivative of this equation. Right-hand side is just x, so right-hand side derivative is just 1. Now left-hand side derivative is sine of y. And now to calculate left-hand side derivative using the rules that we have studied regarding implicitly given functions, we need to do derivative normally like with y, and then like derivative of function with y, and then multiply times y prime. So derivative of sine is cosine, so left-hand side derivative will equal cosine of y, that will be the derivative of sine, and then we need to multiply times y prime. Now here is what we have. Derivative of the left-hand side, which is cosine y times y prime, equals derivative of the right-hand side, which is just 1. So once again, derivative of the left-hand side, which happens to be cosine of y times y prime, equals derivative of the right-hand side, which is 1. But from here we can easily solve y prime, the derivative of y, and that equals 1 over cosine of y. Now this formula is good enough as derivative of an implicitly given function. However, this is not good enough for our purpose because we want derivative in terms of x. So we want it in terms of x. In terms of x. And what does it mean? We know that x equals sine of y. X equals sine of y. So we want to express it in terms of sine of y and then plug in x for sine of y and not in terms of cosine of y. So basically we want to express cosine of y in terms of sine. Because again, sine of y just equals cosine. And how do we do that? Well, we can use the main trigonometric identity that says that sine of anything squared plus cosine of the same thing squared equals y. So now I will use it with y. So sine squared of y plus cosine squared of y equals 1. And since we need to express cosine, so first we express cosine squared. And that is just 1 minus sine squared x, the sine squared y. And then we do square root. So cosine of y equals square root of 1 minus sine squared y. Now you may argue that there should be positive or negative square root. However, here is where the restriction comes into play. Remember that sine of y equals x, so x equals sine of y, and in order for, let's say, y equals sine inverse of x, and x equals sine of y, and in order for the inverse function to be well defined, so the argument of y, the argument of sine, which is y, should be between negative pi over 2 and pi over 2. And now we can actually indicate this on the picture, so on the picture it's more clear. Y is the angle, and it runs between negative pi over 2 and pi over 2, which means it runs in the right hand side of the circle. But in the right hand side of the circle, cosine of y will be always positive. Because cosine is the x coordinate, on this side cosine is positive, on the left hand side cosine will be negative. But since our angle is between negative pi over 2 and pi over 2, so it is located on the right hand side of the circle, so cosine will always be positive, actually not negative. And therefore, when we solve for cosine, it will not be positive or negative square root, it will always be positive square root. So now, using this formula for cosine, we can plug it into the derivative. And it will end up 1 over square root of 1 minus sine squared x, sine squared of y. But since sine of y equals x, so it's a 1 over square root of 1 minus x squared. And this is precisely the formula that we need. So we have actually expressed the derivative of this function as a formula involving x. So here is what we got. If y is inverse, what is this? Y is inverse sine of x, then the derivative equals 1 over square root of 1 minus x squared. So this is the derivative of the inverse sine.